Today we are going to see the problem of GFG GeeksforGeeks problem of the day. Coco eating bananas. Problem statement says Coco is given an array where each element represents a pile of bananas. She has exactly k hours to eat all the bananas. Each hour Coco can choose one pile and eat up to s bananas from it. If the pile has at least s bananas, she eats exactly s bananas. If the pile has fewer than s bananas, she eats the entire pile in that hour. Coco can only eat from one pile per hour. Your task is to find the minimum value of s bananas per hour such that Coco can finish all the piles within k hours. So basically the problem statement says that I need to find the minimum number of value of s, that is the maximum consumption I can make, such that I can finish all the piles within the given stipulated amount of time. That is they are measuring it as a k. So if you take the first example, here we have the piles as 3, 6, 7 and 11, and if you take and the answer is 4, because at a time Coco can eat 4 bananas at max. So it will complete the first pile in 1 hour, and it will complete the second pile in 2 hours, because in the first time it can eat 4 bananas and we are left out with 2 bananas. So it will complete that in the second hour. So it will take 2 hours to complete 6 bananas. Similarly for 7 it will take 2 hours, whereas for 11 it will complete it in the form of 4 plus 4 plus 3. So it will take 3 hours. In total it will take 8 hours, which is less than or equal to 8. So the minimum value of s will be 4. Now you can say that what if my value of s is 3? If the value of s is 3, then given 3, 6, 7 and 11, it will take Coco, if the value of s is 3, it will take Coco for the first pile to complete in 1 hour. For the second pile it will complete in 2 hours. For the third pile it will take 3 plus 3 plus 1, so 3 hours. And for the fourth pile it will take 3 plus 3 plus 3 plus 2. This will be 4 hours. So in total it will be 4 plus 3 7, 7 plus 2 9, 9 plus 1 10. Total it will take 10 hours. So if you see the pattern here, I can clearly say that if I choose a value 3, then it is taking 10 hours. Now if I choose a value 2, then it will take more than 10 hours, and if I choose a value 1, it will take more than the number of hours that will be taken by 2. It is clearly a binary search problem where initially I'll be having false, 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 and at one point of time I'll encounter true, true. From then onwards I'll encounter true every time. I mean true in the sense I'll be completing all the piles in less than the stipulated time which the problem statement is mentioning. I have done the same. Today's lead code is also a similar kind of binary search problem. I have already made a video on it. You can check out the same thing in the cards which I provide. Let's code it up. First I will be taking what is the size of the array, then my low will be 1 and high will be maximum value that array can value of array can go is 1 e power 6. So 1 e power 6. Then I'll initially starting considering my answer as -1 initially, and while low less than or equal to high, what I'll do is I'll calculate the first. Initially I'll calculate the mid value. Now I'll suppose there is a black box function of can achieve. If I am achieving, where I will be passing my array k and mid value. If I am able to achieve it, what I need to do? here we can clearly see that we need to always minimize the value. So I'll be reducing my high to mid minus 1, and my answer I will be always storing that value. If I am not able to achieve it, I need to increase the capacity to eat the bananas. So basically I'll be keeping it as low equals to mid plus 1, and I'll be finally returning the answer. Now I'll need to write this boolean function of can achieve. I'll be taking the 3 inputs. Now I'll be going through each element in the array, and I'll be checking whether I'll be reducing that values from my maximum horse in my hand. Maximum horse in my hand is k. I'll represent it in the good terminology. Maximum horse in my hand is k. So I'll be reducing the horse based on the amount of bananas it can eat. Why am I taking this? This is a way I can get the integer value. Suppose if I am dividing 6 divided by 4 with integer division, it will always give me a floor value of 1 floor value, but I want the ceil value. So first I'm converting this mid to float, and I'm dividing that with the value of bananas in that pile, so that, and now I'll be getting this value in the form of float. It will be around 6 by 4, that will be 3 by 2, 1.5. So 1.5 ceil of 1.5 will be 2, so I'll be reducing my hours with 2. So here we have the condition that if my number of hours is greater than or equal to k 0, if my number of hours is greater than or equal to 0, then I can clearly say that I need to return true, because I am left out with the hours, and I am able to achieve the task. I am able to eat all the piles within the stipulated time, else I will be returning the false. Let's run it and check it. Yeah, let's try submitting it. Yeah, it's successfully solved. The time complexity will be order of high value will be 1 e power 6, 1 e power 6 into log of 1 e power 6. That will be my time complexity. Here n can go till 10 to the power 5. So it will be 1 e power n log 1 e power 6. So that will be n log 1 e power 6 time complexity, and the space complexity will be order of 1. Since we are not storing any extra value apart from the answer which I am supposed to return, it is an order of 1. And if you want me to do a video on any kind of any problem, do let me know in the comment. And if you have any doubts in this problem, we will have the comment section as a discussion form, so that it will be enabled for us. Thank you.